One of the biggest cosmological mysteries today is trying to figure out the age of the universe. How old is it exactly? And one of the, easier ways of doing this is by looking at, actually right here, the Milky Way galaxy, our home. By trying to discover some of the oldest objects in the Milky Way, we can then sort of start making assumptions about the total age of the universe, because it's believed that the Milky Way most likely started forming pretty much almost right after the beginning of the universe. But when it comes to discovering some of the oldest objects here, this is of course when things get a little bit tricky. And interestingly enough, something like a couple of decades ago, there was actually an unusual discovery of a star that might have been potentially even older than the universe, kind of. The iconic star HD 140283, also referred to as the Methuselah star. A star that appeared to be, at first, roughly around 14 billion years old, which is obviously older than the universe. But in this case, the age uncertainty was also very large. And more specifically, not so long ago, we've discussed another really important study that essentially establishes that the age of the star is much lower. It's now believed to be something like 11 to maybe 12 billion years old, and these earlier calculations were most likely not entirely correct. And so what's the new record holder then in the Milky Way? Is there something else here that we can actually determine to be even older in order to potentially discover the age of the universe? Well, when it comes to individual stars, at the moment it seems to be this one. Relatively complex name, no shorter nicknames, but in essence it's believed to be about 13.5 billion years old. It's approximately 2000 light years away from planet Earth, and it seems to be a star that's a little bit less massive than the Sun, with extremely low metallicity, implying that it is very old. So this is probably one of the first individual stars that formed in a galaxy, or at least one of the oldest remaining stars. But in order to find something even older, and to then calculate the age of the galaxy, we have to look at something entirely different. We actually have to look at some of the most mysterious objects in the entire universe. The objects we know very little about. We have to examine this: globular clusters. Mysterious formations that seem to be present in most galaxies out there, and the formations that are usually the oldest objects in the entire galaxy. This one being no exception. This is one of the biggest ones near us, known as Omega Centauri. And even though recent examinations by the Gaia telescope discovered that there are quite a lot of stars inside the thick disk that seem to be at least 13 billion years old, implying that the disk most likely formed much earlier than we predicted, around the same time Hubble telescope analyzed one of the clusters right here known as NGC 6652, discovering that its age is most likely much older, at least 13.6 billion years old. Although in this particular case, these types of objects most likely had several generations of stars and several types of star formation, so here we're just talking about the absolute age, or the age when these clusters started forming themselves. And so some stars here are definitely much younger, but quite a lot of stars are actually that old. But much more recently, just a couple of weeks ago, there was actually another study that finally confirmed an even older cluster that's basically just as old as the universe itself, 13.8 billion years old. The cluster you see right here, the very famous M92 or Massey 92, that's around 27,000 light years away from planet Earth, and is located slightly away from the galactic disk. Now, just like so many other clusters, it's actually orbiting in the opposite direction from a lot of other stars, suggesting that it either came from somewhere else, or most likely was born before the galaxy established its rotation. And so in this recent study that you can find in the description, scientists behind the recent study used a somewhat complex statistical analysis, or essentially thousands of computer simulations, in order to figure out what the absolute age of this cluster was, based on the colors it was producing and based on the observations we see so far. And so after 20,000 such simulations, by comparing the colors and brightness, they established that it's most likely 13.8 billion years old, plus minus 700 million years. Although in this case, that error of approximately 5% is actually because we're not entirely certain how far away this cluster is from planet Earth. In other words, there's a bit of a distance discrepancy, which means that we're not entirely sure how big or how small it is. These errors are most likely going to disappear completely once we get additional observations from telescopes like Gaia. And so even though previous assumptions or previous calculations would usually just use a few stars from the cluster to try to determine its age, here the calculations involved the collection of all stars, focusing on the total brightness and the total color coming from this object. Also discovering that its size is approximately 109 light years across, and it has a mass of approximately 330 solar masses. But once again, it's important to remember that this is a collection of stars from different populations, and in this case, in this cluster, at least 2 populations are known. Some that were most likely created 13.8 billion years ago, but some that were created maybe 6 to 7 billion years ago. So the actual age discrepancy here is pretty large. Nevertheless, by figuring out the age of these objects, it becomes possible to confirm the age of the Milky Way, and more importantly, the age of the entire universe. Because since these are the oldest objects out there, determining their age helps us work out when all of this most likely started. But when it comes to these clusters, it's also important to understand their mysteries and their overall properties. For example, we know that none of the clusters today contain any active star formation, and pretty much all of them in the Milky Way galaxy are over 11 billion years old. We actually know of 150 such clusters, although there are probably more of them hiding, but all of them are super old. And in modern cosmology, this kind of implies one thing. It suggests that there was probably some kind of a very active period in the early universe where huge amounts of these clusters were formed all at the same time, for strange reasons that we still don't understand, and ever since then, they basically remain by themselves in the rest of the galaxy, maybe occasionally interacting with something else, and maybe sometimes forming new stars, but very rarely. So there was basically some kind of a period of globular star formation. And this is a really intriguing period because it suggests that there was something in the early universe that encouraged formation of these objects. Some of the observations from the James Webb Space Telescope might have actually discovered the preliminary signs of the formation of these clusters, but it still hasn't been confirmed. Either way though, they seem to be the first collections of stars to form in the entire universe. And they also represent the densest regions of stars, often containing thousands and even millions of stars, all in a tiny volume of space. Surprisingly, they never really collide, and they all seem to dance around the center without really any major interaction. But because of the proximity of the stars to each other, it's quite unlikely that there are any planets here, or anything more complex than a single star. Even a binary system would not survive here. Actually, there was a potential planet discovered not so long ago around one of the pulsars in these clusters, but it's actually believed to have been captured from somewhere else, and it's most likely just a lost world that was just captured by accident. And so a lot of modern theories suggest that any planets in these clusters very likely escape and become rogue planets traveling across the galaxy. So for example, a direct search for planets in 47 Tucanae cluster came up completely negative. No planets found whatsoever. And because a lot of them often contain only much lighter elements, such as helium and hydrogen, it's now believed that they just lack a lot of heavier elements to create terrestrial planets, or to potentially even create more complex planets we often expect around typical stars. Nevertheless, these clusters are still really interesting, mostly because they seem to have a direct role in galactic evolution that's still not really understood. For example, in many different galaxies, especially elliptical or lenticular galaxies, there's a very unusual relationship between the central supermassive black hole and all of the clusters in the region. The mass of the supermassive black hole is often extremely close to the combined mass of all of the globular clusters. And that by itself is already kind of strange. Nobody knows why this is so. Moreover, there's really no way to explain their formation just yet. We know that they exist pretty much everywhere, and they have a connection to a lot of different galaxies, but how they formed, nobody knows. There are some potential hints from galaxies like the Antenna galaxy right here, where scientists have actually found a cluster of globular clusters that seems to span hundreds of light years across, which potentially shows how they might have formed. So here it will be a collection of different smaller clusters, eventually merging into something larger, where some other answers potentially come from a little bit closer to home. For example, this right here, Westerlund 1, is a region of very large star formation, a kind of a superstar cluster. And so this could be maybe a precursor to globular clusters, or at least something that would have become one if it had a little bit more mass. Here's another really famous one in the Large Magellanic Cloud, known as R136. But at least for now, these are just suggestions, and there's really no way to answer any of these questions until we get more observations from the James Webb, and until we can actually see some of the periods in the early universe directly showing us the formation of these clusters 12 to 13 billion years ago. And of course, based on the observations from this particular cluster, M92, we can now more or less confirm the age of the Milky Way as well, and to some extent the age of the universe, 13.8 billion years. So definitely a pretty exciting discovery, but because we have so many clusters to look at, it will be interesting to see if the scientists discover something else that might be potentially a little bit more mysterious, or possibly create some kind of a mystery when it comes to the age of the universe. We'll see where all of this goes in future studies. So basically, by applying a same technique to other clusters, scientists might find something really cool. But on that note, thank you for watching, subscribe, check out some of the previous videos on similar topics in the description below, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.